is 120. Or in an isosceles triangle, two sides and two angles are equal. Sum of three angles of triangle is 180. This is 120. So 60 divided by 2. These two angles are 30 degree. Now angle BOB dash is equals to BOB dash is equals to angle BOA plus angle OAB dash. Angle BOA 60 degree, OAB dash AOB dash is 30, so this is 90 degree. So this is a right triangle. So in triangle BOB dash, BB dash square is equals to OB square plus OB dash square. BB dash is, this is 1 unit and this is 1 unit, that is 1 plus 1, 2. So 2 square. OB is 1 because it is given that magnitude of this is 1. Now we want to find the value of this. 4, 2 square, 4 minus 1 is 3. A cap minus B cap. Therefore, magnitude of A cap minus B cap is square root of 3. If A vector and B vector represents two adjacent sides, A vector and B vector represents two adjacent sides, A vector and B vector represents two adjacent sides AB and BC respectively of a parallelogram ABCD, then show that its diagonal AC vector and DP vector are equal to vector A plus B vector and A vector minus B vector. AB vector is A, BC vector is B. This is AC vector and DB vector. Because ABCD is a parallelogram, therefore opposite sides are equal. AB vector is equals to DC vector is equals to A, AD vector is equals to BC vector is equals to B vector. Now in triangle ACB या ABC, by triangle of vector addition, AB plus BC vector is equals to AC vector, A vector plus B vector. Therefore diagonal AC is equals to A vector plus B vector. Now in triangle ABD, AD vector plus DB vector is equals to AB vector. AD is B vector, DB we want to find out. AB is A vector. So DB vector is equals to A vector minus minus B vector. So the diagonal of the parallelograms are A plus B vector and the other diagonal is A vector minus B vector. Now next one, vectors drawn from the origin to the points A, B and C are respectively A vector, B vector and 4A vector minus 3B vector. Find AC and BC. Find AC vector and BC vector. Now in triangle AOC, OA vector plus AC vector is equals to OC vector. OA vector has value 1, OC 4A minus 3B. AC vector is equals to 4A minus 3B. 4 minus 1, 3A minus 3B. Therefore vector AC has value 3 times A vector minus B vector. Now we want to find the value of BC vector. Now in triangle OBC, OB vector plus BC vector is equals to OC vector. B vector plus OC vector has value 4A vector minus 3B vector. Therefore BC vector is equals to 4A minus 3B minus B. So 4A vector minus 4B vector. So BC vector has value 4 times A vector minus B vector. Now next one, if A vector, B vector, C vector, D vector are distinct non-zero vectors represented by directed line segment from the origin to the points A, B, C, D respectively, and if B vector minus A vector is equals to C vector minus D vector, then prove that ABCD is parallelogram. ABCD are distinct non-zero points. A, B, C, D. O is the point of origin. O is the point of origin. O, A vector, B vector, this is C vector and D vector. Now we have given that B vector minus A vector is equals to C vector minus D vector. B vector, that is OB vector, minus OA is equals to OC minus OD vector. Now in triangle AOB, equals to B vector minus A vector. Now in triangle OCD, in triangle OCD, OC vector plus CD vector is equals to OD vector or we can write it as AB vector is equals to OB vector minus OA vector. Now CD vector is equals to OD vector minus OC vector. CD vector, or we can write it as OC vector minus OD vector is equals to negative of CD vector. Or instead of this, we can write it as DC vector, OC minus OD. Now this is given OB vector minus OA vector is equals to OC vector minus OD. That is AB vector is equals to DC. If AB is equals to DC, then ABCD is a parallelogram. Opposite sides are equal, therefore ABCD is a parallelogram. Now next one. If A, B, P, Q, R are 5 points in a plane, show that sum of vectors AP, AQ, AR, PB, PBQB and RB vector is 3 times AB vector. A, B, P, Q, R are 5 points in a plane. A, B, P, Q and R are 5 points in a plane. Now in triangle APB, AP vector plus PB vector is equals to AB vector. In triangle AQB, AQ vector plus QB vector is equals to AB vector. In triangle ARB, AR vector plus RB vector is equals to AB vector. Now add these 3 equations. Add 1, 2 and 3. AP plus PB plus AQ plus QB plus AR plus RB vector is equals to, on right hand side we get AB vector plus AB vector plus AB vector. That is 3 times AB vector. That is what we want to prove. Let O be the center of regular hexagon. Let O be the center of regular hexagon. Find the sum of vectors OA vector, OB, OC, OD, OE and OF. Find the sum of these vectors. We know that center of regular hexagon bisects the diagonals. Therefore, OA vector is equals to negative of OD. OB vector is equals to negative of OE. And OC vector is equals to negative of OF. When it goes on the left hand side, it becomes OA plus OD vector is equals to 0 vector. OB plus OC is equals to 0 vector. OC plus OF is equals to 0 vector. Now add these three equations. On left hand side, OA, we want to find the sum of this. So we can write it as OA plus OD plus OB plus OC vector, OB plus OE vector plus OC plus OF vector. This has sum equals to 0 vector. Therefore, the sum of these vectors is equals to 0 vector. For any two vectors, A vector and B vector, prove that modulus of A plus B vector is less than is equals to this. Modulus of A vector minus B vector and modulus of A vector minus B vector is greater than this. When A vector and B vector are non-collinear, it means they not lie in a same line. Let vector A be represented by OA and B be represented by vector AB. Then OA vector plus AB vector is equals to OB vector. So OB vector is equals to A vector plus B vector. Now magnitude of A vector is OA vector. Magnitude of B vector is OB vector. And magnitude of A plus B vector is OB vector. AB is OB vector. Since the sum of two sides of triangle is always greater than any one side of the triangle, therefore this is greater than any one side of the triangle. Sum of two sides is greater, so we can write it as OA vector plus AB vector. Sum of two sides is greater than OA plus AB is greater than OB. Or we can say vector magnitude, B vector, OB is A vector plus B vector, is less than magnitude of A vector plus B vector. Now case second, when the points A vector and B vector are collinear, when A vector and B vector are collinear points, it means it lies in the same line. Then OA vector is equals to A vector, AB vector is equals to B vector, and OB vector is sum of A vector and B vector. OB vector is equals to sum of these two vectors. Magnitude of OA is equals to vector A vector magnitude.